So here's example 8, and directions are to rationalize the denominator. Now for the first problem, our denominator is cubed root of 2. So let's go through our 3 questions. How many do I have? And so we're talking about 2's. How many 2's do I have? I've only got one of them. How many do I want to have? I want to have 3 of them. I want to have a perfect cube. So how many more do I need? I need 2 more. I have 1, I want 3. And that's what we multiply by in the top and the bottom. We multiply by 2 squared. Well, what is 2 squared? 2 squared is 4. Now, I'm not going to write that in the bottom, though. In the bottom, I'm literally going to write 2 cubed, because I had 1 2 originally. I multiplied by 2 more. That gets me 3 of them. And I write it in that way in the bottom because it makes it more clear that my cube root and my cube undo each other. And when they undo each other, all I'm left with is the 2. And I have successfully rationalized my denominator because I no longer have a radical in the bottom. Let's go ahead and look at the second example. In this second example here, we have a 9 in the bottom. Whenever you have a number that can be written as a power, do so. So our first thing we're going to do is rewrite this as 3 squared. Now, how many do I have? How many 3's do I have? I have 2 of them. How many do I want to have? I want to have 3 of them because I have a cube root. So how many more do I need? I only need 1 more. That's what I multiply by in the top and the bottom. So in the top, I have 2 cubed roots of 3. And in the bottom, I've got the cubed root of 3 cubed. But again, the cube root and the cube undo one another. So that all I'm left with is a 3 in the bottom. And now I've rationalized the denominator. Let's go ahead and go to the third example. So now again, I have a 9 again. So I'm again going to rewrite this original problem before I start asking my questions. Where the 9 I'm going to write as 3 squared. And then I still have the x to the 4th. Now I know I'm going to need to multiply by a cubed root in the top and a cubed root in the bottom. So I'm going to go ahead and start off with just that written out. Now as I go through my 3 questions, I need to rationalize for both the 3's and the x's. And I'm just going to treat them separate. I'm going to start off with just looking at the 3's. Just looking at the 3's, how many do I have? I have 2 of them. How many do I want to have? I want to have 3 of them. So how many more do I need? I need 1 more. Then I move on to the x's. How many x's do I have? I have 4 of them. How many do I want to have? Well, I want to have a multiple of 3. So I would like to have either 3, 6, 9, 12, etc. 3 is too small because I already have 4 of them. But then how about 6? I could build myself up to 6. So if I want to build myself up to 6, I need 2 more. So that's what I'm going to multiply by, is the 2 more that I need. So up top, I have cubed root of 3x squared y squared. And in the bottom, I originally had 2 3's, now I've got 3 3's. I originally had 4 x's, now I have 6 x's. My top doesn't simplify at all. My bottom, cubed root of 3 cubed is 3. Cube root of x to the 6th is x squared. Because remember that 6 over 3, that's x squared. And there's my answer.